can click. Hello everyone, I'm ready to do this, and I'm just gonna try and start the live chat. Just trying to edit a bit of the setting. Here is the physics. Yes, thanks for joining. People already joining, and I'm gonna just do it. Yesterday we went through a lot of questions, and luckily a number of the questions were on the paper today. My students were very happy, and a number of them have received some comments as well online to say it was quite good. So I want to do the same thing with the physics. So what I'm gonna do, I'm gonna just use a similar method that I used yesterday. Alice, if you're watching, well done. Your sister said to me that you were watching yesterday as well. So I'm gonna put on up the questions. They are quite small, but don't you worry, I'm going to explain which area I'm talking about. Now, that particular graph is on about it's actually a speed time graph, right? A distance time graph. Now, you all would remember that how you calculate speed is equal to distance divided by the time. But when you're giving your graph on the exam, you could be asked to identify other things. This is a question that I've pulled up from the exam pro, and on this question, it clearly says a bus is taking some children to school. The bus has to stop a few minutes. The figure below shows the distance time graph for part of the journey. Now, on this side, on the y-axis, it gives you the distance in meters, and then on the x-axis, it gives you the time in seconds. The first question says it says, how far has the bus traveled in 20 seconds? Very important. Go to the time section, locate 20 seconds, and then trace it to the distance it has covered on the side of the distance in meters. And on this one is 100. You write down 100, and then it says describe the motion of the bus between 20 seconds and 30 seconds. It is actually stationary. Stationary. There is no movement. Hello, Clarissa. Hello. Thanks for joining me. And then he said, describe the motion of the bus, 30 seconds, between 30 seconds and 60 seconds, and it is obviously accelerating. All right. If you cannot see it very clearly, do not despair. I am trying my best to do some explanation. I'll just bring this closer. So this is the next set of questions I'm working through. And the next one says, show clearly on the figure below how you obtained your answer. What I just want to say, remind you about data question. The answer, remember the answer is there. So what you've got to do, you've got to just walk through with your answers. No worries, Clarice, thank you so much. I hope I'm saying your name properly. Yeah. Okay, no worries, no worries. I appreciate your gratitude. I mean, when people say thank you for what you do, it makes you want to do more. All right, I'm really tired today because it's been hectic, as you know, but I've made a promise. I will try and keep the promise. I would only not do a video I've said I've done if it's impossible. If it's possible by any chance, I would do it. It was so hectic today. I actually had a bit of a migraine, which I have not had since I've been in secondary or maybe university. Had a migraine. I just prayed, oh God, help me, and I prayed and I declared against the migraine. It disappeared. I was fine within 5 minutes, and I was able to complete my day at school, and I'm able to do this one now. So I'm quite happy that I'm able to do this, and I hope you can hear me very clearly. And then there's a question about, it says later in the journey, the bus is moving at and has a 500,000 joules of kinetic energy. The brakes are applied and the bus stops. How much work is needed to stop the bus? It is the same amount of force. It is still 500,000 joules that's needed as the work done. All right, thank you so much. Thank you. I am already feeling better. Thank you. And then he said the bus stopped in a distance of 25 meters. Calculate the force that was needed to stop the bus. All right. So when you do that, it is the 500 that you just said was the work done equals the force the times the 25 that you've been given in your meters. And when you rearrange that, you will discover that rearranging that should give you 500,000 divided by 25. This is not the formula I'm using. So that should give you 500 divided by 25, which is equal to F when you rearrange that. And then that will give you your answer as to 20,000 newtons. All right, that was the amount of force. And he said, what happens to the kinetic energy of the bus as it is braking? Now, the kinetic energy in the bus is applied to the brakes, yeah, transferred to the brakes as in form of heat energy. I'm just going through this really quickly because what I want to do is I want to go through as many topics as possible, and I also want to look at the required practical, which is both for higher and foundation. Because I always look at the required practical is always important. It's always handy for those who are doing higher as well. Let me just pause to say that I feel very strongly about forces. I woke up this morning and my waking thoughts were, oh, I need to do forces, forces. So that's why I'm going through a lot of force questions on forces. First of all, I just want to complete that. And a few things I want to remind you. That's a diagram of a person, for instance. Yeah, maybe a diver or someone who's falling out of a parachute or something. And then they will ask you to describe the forces acting on the person. In this particular question, it says, let me read it very specifically so I don't mess it up. It says, an actor is attached to a wire so that she can hang above the stage. Look at the figure. So that is the figure of the actor hanging above. And it says, on the figure above, draw two arrows to show the forces acting on the actor. So from the center of the mass, you draw one force going upwards, and you draw one coming downwards. That's the weight and the gravity that are acting against the body of the person. And it says what two forces are acting on the actor. So you have the tension force and you also have the gravitational force. They are the two forces that are acting on the person. And because they're both opposite and equal, the resultant force at the end of the day cancel each other out. And because I just mentioned resultant force, I am just going to quickly go over resultant forces for you. All right. Now, if you have resultant forces, to calculate resultant forces, this is what I'm explaining. To calculate the resultant force, this is what you do. If you have a force acting in that way, say it is 10 newtons, and you have another one acting there as 2 newtons, because they're acting on opposite direction, say that's your object, is going to be 10 take away 2, which is 8 newtons. However, if it was in this direction that you had 10 newtons and you had another one which is 2 newtons, is going to be 10 plus 2, which is 12 newtons. So if they are acting in the same direction, you add them up. If they're acting in opposite direction, you take them away. You minus one from, or you subtract them one from the other to get your resultant force. You subtract the little one from the bigger one. And then because I'm just on this point, I just want to remind you of scalar and vector quantities. Yeah, this is part of what is covered here. Scalar quantities and vector quantities. Yes, scalar has got size, but no direction, such as your speed, your time. As example, they've got size, no direction, and vector has got size and direction, and that will be your force. Yeah, for example, e.g. force is got size, it's got direction, and that will be like your acceleration as well. Acceleration. Okay. Now I'm trying very hard to keep to what I've got here, but I'm resisting not doing that. He says, thank you so much. Will you be doing electromagnetism? I can mention a few solenoid things like your solenoid and your electromagnet. What you need to remember, I really don't want to deviate, but someone said it. I might as well just refer to that quickly. Yeah, remember your solenoid. Yeah, when you have a material that you uh, put a wire around, you end up with a gravitational field around it. A few things you need to remember about this gravitational field is that these lines go in the same direction. All right, so even though that's the north and the south pole, what happens is they go. So you have a magnet with a coil of wire, you have your solenoid, and then the forces go in the same direction, and they are all the force around it, and every time is the same. And how you increase for this solenoid to become an electromagnet, you have to use an iron bar as the material that's inside the coil of wire. And for you to increase the strength, you have to increase the number of coil of wire around your core. So you can have your metal core. When you increase the number of wires around it, you increase you can increase the field strength, and you can also increase how important it is, how strong your electromagnet is. All right, that's just quickly about electromagnet. I don't want to lose focus of the things I've prepared. I want to stick with forces. If you haven't done your revision of forces, please, I need you to do revision of forces. So it says this question is asking still on the actor's body. It says an actor has a mass of 70 grams. So that is the mass of this actor. 70 kg, and a gravitational field strength. You will notice that this was also on your P1. The cut across is 9.8 newtons per kilogram. And then the question is use the following equation. Weight is equal to, so weight is equal to mass times the gravitational field strength, right? It says give your answers to two significant figures. Now this is just going to be 70 times 9.8, which should give you a total of 686. All right, it says you should give this answer to two significant figures. Now when you're asked to do two significant figures, I beg of you, if you're asked to do two significant figures or three significant figures, that is 1 mark. So you ensure that you round it off. So this will be 690. So that will be 690 newtons. This is to two significant figures. That carries on to the next question, which then reads, a motor pulls vertically upwards on the wire with a force of 72. So if you have weight, if that is the weight that's acting downwards, so let's imagine that this weight is downward at 690 newtons. They're not telling you there's another one that's 720 newtons. And the question obviously is a resultant force. This was what I told you before. You take it away from that and you're going to end up with 30 newtons as your resultant force. I feel very strongly about these questions, and they are so easy you don't even want to miss out on them. He said another actor has a mass of 65 kg. This is a different question. 65 kg, that is the mass of another actor. Remember that mass is just the material that the person has. If you want to work out the weight, you need to know the average size of the force and you multiply it by that, you work out the weight. All right, and it says the actor is attached to the wire and the motor pulls her vertically upwards. The resultant force is 25 newtons. So now we have the resultant force. So it's going to be equal to the mass times, say, calculate the accelerator. To calculate the accelerator A, so because we have this is actually 25 newtons equal to 65A, because that's what it means. So if you were to divide that by 2, but divide this by 20, 25 newtons. So for you to work out A is going to be 25 divided by 65, and your answer, you get 0.38, and it's meters per second square. That is the acceleration for that. Remember that physics is a total of 30 The questions are a total of 30%. So you need to remember that and get all your calculations right. It says for this graph, there is this little graph that I have here. Is showing you the graph of that graph I just showed you is graph of the force applied against the extension in centimeters. This is talking about Newton's second law. This is an experiment that examines the springs when you look at how weight affects string extension, deformation, region, and elastic limit, and all of that for those who are writing the higher paper. Okay, so if you look at that, it says write down the equation that links the force applied and the extension of the spring. So what it is force applied, force applied, the force applied is equal to K, which is the constant, the spring constant. Okay, the spring constant, and that is times the extension in centimeters, or what you're giving. So it's actually F is equal to little k times E. All right. So, and then there is a question that says, identify the pattern shown in the figure above. Anytime you see the diagram of that drawn, anytime you see the figure drawn, it's always a line going through the origin. So extension is directly proportional to the force applied because it is a straight line through the origin. And it says, give one way the student could improve her investigation. I picked on that because there is always this question about how you can improve an experiment. Well, you need to, if you understand how the experiment works, then you will be able to explain how to improve it. In that particular case, the student might do more springs so that they can have a larger way of a larger base, as it were, a bigger sample size, as it were, so that their comparison can be fairer, they can have a better basis for comparison. All right, this question is about braking distance. Braking distance, stopping distance, you need to remember how to work it out. I'm just going to use the question so I don't spend too much time. He said a car makes an emergency stop that's been driving along the road, and the thinking distance, we're going to work with this. The thinking distance is, let's say here it is 12 meters, and then the braking distance is 24. So the braking distance is 24 meters. Now there are a few questions. He said, what is the stopping distance? All right, the stopping distance is say what the stopping distance is the time it takes for the person to think, slam on the brake, and brake. Actually, the stopping distance. Sorry, is asking for the stopping distance. So just this is about someone that's driving a car and suddenly having to slam on the brake. So if a person is driving and they suddenly see another car coming towards them, or a child or a football being rolling in front of them ahead, what they're going to do, they're going to think, oh, I need to bring this car to a stop. That is the thinking distance. So from the time they see the danger and when they decide to actually brake, that is the thinking distance. Because when they see the car does not stop, or when they see they don't brake instantly, yes, you will brake instantly, but there is still always a little distance that the car would move before you slam on the brake. So when you then slam on the brake, the car does not come to a stop. The distance the car will still move a little before it stops from when you stepped on the brake is the braking distance. So when you add the thinking distance and the braking distance together, you get your stopping distance. So the stopping distance is the thinking distance plus the braking distance. Okay, now the way they could ask this as a 6-mark question is they could say to you, what are the factors that could affect these ones? Please, Please pay attention. For the thinking distance, it's about the person who's driving the car. So if someone is under the influence of alcohol, for example, their thinking distance will be longer. If this is the normal thinking distance for average drivers in the UK, for instance, the person who's under the influence of alcohol might move it to up to about maybe 20 or more meters, because they are slower in reacting, because that's one effect of alcohol. It makes you slower in your way you react. All right, it makes you slower in the way you react. You're much slower in action because of the influence of the alcohol. All right, so when that happens, your thinking distance is increased. Most likely your braking distance is also going to increase, because your ability to think and react and take action, which is braking at that time, is actually going to be longer, because you're slower with what you're doing. So the person driving, if you're tired, if a person is tired, that could also be a problem. If the person has got problem with their eyesight and they haven't taken proper steps to get medical help, or if they're ill, or if they're in a bad place emotionally, that could affect their thinking distance. Because if you're distracted, you're not going to see the danger as quickly as someone who's focused, someone who's not at alert. So a driver's alertness actually has a huge impact on their thinking distance. When it comes to the braking distance, it has to do with the car and the road. Remember, the friction between the tires and the car and the road is very important in helping the car to come to a stop. How do I mean? If you have a car with one tires, you will not be able to bring the car to a stop quickly enough. You're likely to skid if the road is icy or slippery, or if there's been some oil spill on the road, is bound to affect the rate at which you're going to make your braking distance longer. So for me to repeat that quickly, thinking distance has to do with the individual condition of the person, and the braking distance has to do with the condition of the car, the road, visibility. Maybe if it's a dark, windy night, that's going to affect your braking distance, because that has to do with not you, the driver. You might be in perfect shape, however, the road or the condition may affect it. So if you explain that as I have done, you're bound to get 6 out of 6, because that will give you enough information for the 6-mark question. Now, I want to just quickly re-emphasize the issue of data. Anytime you find a data on your paper, just smile to yourself, because all the answers are on the question. Just read through. Read through. If you read it the first time, you're not sure, read through. If you're given a graph, look at the y-axis. What's the information that you're giving? Look at the x-axis. What's the information you're giving? Use all of this information to answer the question. And if you're required to get 2 marks, or if it's a 2 or 3-mark question, please remember to add the units. Remember to add all your numbers and show you're working. There might be no mark for working, but if you've done your working properly and you forgot to write the final answer, you still get marks. A different exam board do it differently, but I know that if you do that, it's very important to save you some marks that you could have lost. Now, there is a question here, which is the last I want to look at on forces, and is how it's related, or this speed and all that I've been doing. This is showing a diagram of a person. It says the figure below shows an ice skater standing on ice. An ice skater standing on ice is that diagram. Write down the equation that links acceleration, change in velocity with time. So acceleration is equal to change in velocity divided by time. So acceleration A, yeah, acceleration A is equal to change. This is the sign of delta. Delta is what we used to do now. Change in velocity divided by time. So from where the person started and what they covered, you can work out the change. So they started, and then that was their change. And the time we're giving here is 6 minutes. So when you do that, you get for that calculation, 0.333 meters per meters per second square. Okay, and then I have looked at all of those. Yes, thank you so much for answering me before. Um, oh, the person asking the question about jollof rice, I know you is Alex. Yes, yes, yes. Don't worry. I'll fix you some. Don't worry. That's not a problem. Oh, that made me laugh. Okay, I have my own series of questions. Question 11. It says some students did an investigation. It says some students did some investigation, and it's about to study the behavior of waves. Say the figure below shows a ripple tank that they use to model the behavior of waves, and then it said complete the wave fronts on the figure above, then show how the wave is refracted if it passes from the shallow region into the deep region. Now, this is just the unit that this covers is what happens to waves when they get to boundaries. Okay, that is the section of waves that it covers. Now, if you have a, yeah, if you say what happens to you say complete the form to show the waves how it is refracted. So when you have a wave coming in that direction, right? When you go into the deep end, there's going to be a refraction, such as if this is the boundary, is going to get here. Instead of going in that direction, there's going to be a bending, right? It's going to bend in that in okay, that looks like it's still straight. It's going to bend sort of like that direction. And the one that's coming like that should go that way, but it will probably end up going in this direction. So this is showing how it is refracted, because this is refraction. Refraction, remember, is bending of light or bending of waves. If I use rays to demonstrate it to you, you will know what I mean. You will remember what I mean. So let's say you have a surface like so, and there is a ray traveling in this direction. If this is water, for instance, your ray is not going to go like that. It's going to be refracted to go. It will bend a little bit away from this direction. It will bend this way. That is refraction. So refraction is the bending of waves, where bending of rays or waves in this case when it meets with a boundary. There has to be two different media. So one medium is solid, the other one is what do you call it? The other one is, if one is solid, one is liquid. I was just giggling because of what they're talking about the physics tomorrow. On Friday is going to be good, don't you worry. You say explain what happens to the waves as they pass into the deep region. They will speed up, so the waveforms will move apart. They will spread out more because they are speeding up, because they're going into the deeper region. Now, this one is about longitudinal waves and transverse waves. You need to remember the difference. Last year GCS, even though I know it's a different GCS, there were lots of questions about transverse waves and longitudinal waves, and it was really easy to answer them because we had revised them very well. So this question says the waves generated on the surface of the water are transverse. Describe the difference between longitudinal waves and transverse. Number one, longitudinal waves, they is so longitudinal waves, they oscillate, the oscillations are parallel to the direction of the energy transfer. They are parallel to the direction of the energy transfer. And then they show, and then for transverse waves, they are perpendicular. Transverse waves are perpendicular. Okay, so what I'm going to do, I have my own set of questions which I've written. I'm going to go through that because I've gone through the ones I pulled out from the AQA example. So quickly, I want to put this up. I have blown this up a little bit. So this one is about nuclear reactors. It says, how is energy from a nuclear reactor used to in a power station to generate electricity? There are different types of power stations. We have the nuclear one. So if I put this here, you can see this question, and I'm going to explain. You say how is energy from a nuclear station used to generate electricity? These are the steps that you need to remember. During the process of nuclear fission is when you have a giant atom, a giant nucleus, right? Like what's the very popular one that we use? I remember the name. And you have a little neutron, and it hits against that to split it. Very popular one is uranium. Uranium. Uranium is a very popular one. It's heavy. When you use a neutron to hit against it, yeah, it would split it open. In that process of splitting, a huge or massive amount of energy is released, and that energy is used to heat up water to generate steam, and that steam is used to turn a turbine, and the turbine generate, and that way you generate electricity. All right, so the very specific steps is what I've explained to you. By the way, when a little neutron is used to hit against a massive nucleus like that, it can also cause the release of other neutrons. These new neutrons would then go and hit against other massive nuclei, which would then release a lot of energy. Yeah, it is not just paper one. There is link between paper one and paper two, and it's different for different exam board. I know some people who are watching are EDSL, so there are different regions that are covered. Okay. You say, what is nuclear fusion? Nuclear fusion, on the other hand, is the joining together of atomic nuclei and the process in the process by which energy is released in stars. So nuclear fusion, that's joining together, is how energy is released from stars. And then when you compare the uses of nuclear and nuclear fission, yeah, reactors are good because they curtail the reactions. They ensure that the energy that's produced is not wasted. And I just want to put up this picture that shows you the diagram of a nuclear reactor, and that one is showing nuclear fission by a neutron hitting against a really large one. Okay. All right. Now you have that stages of the stages of what do you call it? The stages of the star. This is only for people doing the triple, yeah, physics only. Please go over your star, and then you will be able to get over, you'll be able to prepare yourself for to answer any questions about the stages of a star. It's only for people doing the triple. If you're doing the combined side trilogy, it is not on yours. Okay. So this is the one I told you earlier, the difference between scalar and vector quantities. I have already explained the scalar quantities have just size, like speed. They don't have direction, but a force is a vector quantity, and it has it has both size and direction. And then another one is contact and non-contact forces. Okay, contact and non-contact forces. You have contact force and non-contact force. All right. Contact force is one that acts on an object and it touches the object directly. Yeah, like friction is a contact force, and but gravity is a non-contact force. Another example of contact force is air resistance. If you're driving through air resistance. Another example of non-contact force which acts on the object without necessarily touching the object. Examples of such are gravitational force, magnetic force, electrostatic force. And I say the difference between a force and a mass is just the material an object is made up from. However, weight is what difference between weight and a mass. So weight is the force that's acting on the individual. Okay, I think as I'm looking at these paper that I've put together, I have by and large gone through a lot of the things that I wanted us to do. I have already covered them. Remember, you need to do your force. And then this is an experiment. Remember this experiment about the spring where you have to have the clamp in place, and you have to clamp it down and make sure when you put in the weight, you're measuring the elasticity. Once you do that, you'll be able to work out the difference from the original length and eventually then from how it has stretched. And when you have concluded on that, you draw a graph that looks like that. Remember to always look out for the anomalous point, and then when you draw that, that is your point of deformity where it has gone out of place. Okay, so I decided to do this today. I will do another one tomorrow. I will do a section tomorrow evening just to wrap it up because we have a break tomorrow and the exam is on Friday. I just thought I'll do this ahead of time and I'll be doing that as well. Thank you so much for joining me, and I hope you have found, even if it's a few questions, at least a reminder of the things you've done from year 9. Remember, that's what's important. So I've gone over it. Tomorrow, I will do some more. I pray that you will keep remembering these things. And when you go into your exam on Friday, I am very confident that you will be able to do it and do it very well. You will remember, and it will be a piece of cake. Today, my student said to me, chemistry paper 2 was so easy. I know that physics will even be easier for you. It is my prayer, it is my desire, it is my really wish for you that you would go in and succeed and get the GCSEs you need to move on to the next layer in your next level in life. Take care and God bless you.